Welcome to Diwakar Physics. So in this video, we'll discuss about the numericals of convex and concave lens. So it will be useful for class 10, ICSE, CBSE and for class 12 also. So these questions I have taken from SELINA CONCISE Physics, exercise 5C, you can follow. So first question is, at what position a candle of length 3 cm be placed in front of a convex lens so that its image of length 6 cm be obtained on a screen placed at a distance 30 cm behind the lens? What is the focal length of the lens? Okay, so very first thing you have to do while solving these numericals, so get the information from the question with proper sign convention. Okay, so it's very important to use sign convention here. So you see, at what position a candle of length 3 cm be placed? So first thing they are asking the object distance. So object distance you can put question mark, and the object length usually taken as O, so that is 3 cm. Now sign convention, object is always kept erect, upright, so usually it is in the positive side of y-axis. Okay, so this sign convention you can follow. Object is always kept upright, so we'll put positive sign, it's towards the positive y-axis. Now image in front of a convex lens, so that image of length 6 cm be obtained on a screen. Okay, so real image is obtained on the screen, so this image is real here. So you can understand from the question, it is obtained on the screen, so image length is inverted here, because the images that can be obtained on the screen are real images, and real images are always inverted, so it is in the negative side, so minus 6 cm you can take. Okay, and so placed at a distance 30 cm behind the lens. So now you can see the image is obtained on the screen placed at a distance 30 cm behind the lens. So image is obtained on the screen and it is placed 30 cm behind the lens. So this is positive side of x-axis. So take V. So this is the image is obtained on the screen, so this is the image distance. Always remember, so image distance or object distance are always calculated from the optical center, which is the origin in this Cartesian system of sign convention. Okay, so distances are always measured from optical center. So 30 is the image distance, so plus 30 cm. So these are the information given in the question. Now what formula you have to use? So formula to be used here, so first you have 1 by f is equal to 1 by v minus 1 by u. This is the lens formula or lens equation, and m is equal to I by o, or you can use m is equal to v by u also. That's why we can use the formula I by o is equal to v by u. So this formula can be used here because I, image length and object length are given. Okay, so I'll use this formula for this part. Okay, so we cannot use this formula at this moment because focal length is not given and u is also not given. So two variables are there, so you cannot solve using this. But here you can see I is given, O is given, V is given, then you can find U. Okay, so that's why use this formula. Then first part, I by O is equal to V by U. So I is minus 6. Please use signs also. Sign convention is very important. So minus 2 is equal to 30 by u. So minus 2u equals to 30. And then u equals to 30 upon minus 2. So this gives u is equal to minus 15 centimeter. Okay. So one interesting point I want to tell you here. So whenever you put sign conventions, so only put the signs in the known values. Okay. For example, u is unknown here, and we know u is always negative for all convex, concave, all situations. U is always negative. So don't think to put minus u here. Okay. So don't put the sign of unknown quantities. Put the sign convention or signs of only known quantities. And interestingly, in the answer you will get the correct sign of the unknown value. That is u is equal to minus 15 centimeter. So that's why you see here I have got u negative, so I am correct. In any case, if you get positive, u is positive here, then you may check here some steps are wrong, then you can correct it, re-verify it. Okay, so first part we have got, so object distance is minus 15, that means in front of 15 centimeter in front of the lens you have to keep the object. Now second part they are asking is focal length. So 1 by, so second part, now you can use this 1 by f is equal to 1 by v minus 1 by u. So 1 by f, 1 by v. Now what is v? Plus 30. So we already have this, minus 1 by u. Now see this one carefully. This minus is for formula, and u is minus 15. We have already got. So you have to take this minus sign here. So don't think that minus is already there, so I will not take this. Then you will be wrong. So you have to use sign every time. So 1 by f equals to, so next after putting this values, substituting this known values, what you will do, I suggest to take this negative signs from the denominator to numerator. Okay, because you see minus okay, 1 by minus 3 is minus 1 by 3. So you can take this minus here, no problem, without changing the value. So 1 by 30, no problem. Then minus if you take up, then minus minus plus. So 1 by 15. If there is plus here, then it will be minus. So anyway, don't keep negative signs in the denominator. You can keep it and solve, but what I find most of the students make mistake after that. So I suggest you to take these negative signs immediately into the numerator. Okay. Now it is a simple fraction. You can solve it. So here 1 by f is equal to 1 by 10. So here some students they make mistake. What is that? So they write 0.1 centimeter answer. So they write like this. Okay. So this is absolutely wrong, because you see here you have 1 by f. So if 1 by f is 1 by 10, then simply cross multiplying you will get f is equal to 10 centimeter, not 0.1 centimeter. So you have to be careful that you take the reciprocal here while using this formula and finding f or u or v, whatever it is. So this is very common mistake here. So don't take 0.1 centimeter. So this is wrong. So don't forget to take the reciprocal. See here I have got plus positive 10. So I am correct, because convex lens has positive focal length. Okay, so this way you can solve. first question. So let us go to the second question of the exercise. So it is about concave lens. So the question is like this: a concave lens forms the image of an object kept at a distance 20 centimeter in front of it, at a distance 10 centimeter on the side of the object. What is the nature of the image and the focal length of the lens? So this is the question. Now again, you have to take the information from the question with proper sign convention. So first one, concave lens forms the image of an object kept at a distance 20 centimeter in front of it. So that means this u is minus 20. So in the sign convention, object is always kept the left side, and this is negative side of x-axis. So you will take this u as always negative. Always object is kept this side, negative side of the x-axis. Okay. At a distance 10 centimeter on the side of the object. That means image is formed here only, on the same size of the object. That means v is also negative here. So v is minus 10. And interestingly, concave lens has u, v, f all negative. U, v, f all negative. Remember that. Easy to follow. So u negative, v negative. So only this information is given. Now first thing, nature of image. Real, virtual. Okay, this nature of the image you have to find. So for that you have to use the formula of magnification. So magnification will give you the idea about real and virtual image, and it can give the size also. So for your revision, m is negative for real image. This is for your revision. You can watch my video on sign convention separately I have made. Okay, and m is positive for virtual image. So that's why you have to find m. So what is the formula of m? V by u, I by o. Now here v and u are given, so obviously we will be using this m is equal to v by u. So v by u. V is plus 10, u is minus 10, u is minus 20. So is plus half. That is plus 0.5. So m has no unit. It is just a number. Okay. So what sign we have got? Positive. Positive. Then what is the nature of image then? What is the nature of image? If it is positive, so if the image is virtual. If it is virtual, it is erect. So this is the nature of the image. And you see this value, okay? Only the value part you say. So for your revision, if the value, only the magnitude of m is equal to 1, then it is same size image. You can understand the size of the image also from m. If you see only the magnitude is greater than 1, then it is magnified. Okay, and if you see the value it is less than 1, then it is diminished. This is for your revision. At the same time, while solving the numerical, you can revise the sign convention and other factors also. So what is the value we have got here? Plus 0.5. So plus has given it is a virtual image, and this only the value without sign. You see, if it 0.5, so 0.5 is less than 1, so image is diminished. They may ask you the size also. then you can write diminished. But in this question they have not asked the size. So for your revision I have done. Next portion of the question is to find the focal length. Then we have u and v. So we have ready-made formula. 1 by f is equal to 1 by v minus 1 by u. Then use this formula to find the focal length. So 1 by v is minus 10 minus u is minus 20. So again you see signs are very important. Sign conventions very important. And in the ICSE exam class 10, if you substitute the value in the formula with the proper signs, according to sign convention, then you get 1 marks here. This is the marking scheme. So easy to score in numericals. Okay, then we'll proceed. So what I told in the previous question, remove this sign from the denominator. Then I will write 1 by 10 plus 1 by 20. Then 1 by f equals to, take LCM, and solve. 1 by f equals to minus 1 by 20. And don't divide minus 1 by 20 and write 0.005. So it is f is equal to minus 20 centimeter. Now here you have got f is equal to negative 20. So it's correct because focal length of concave lens is negative. So you have got the right answer with proper sign. So this way we have to solve for concave lens. Okay, so we'll go to next question. The focal length of a convex lens is 25 centimeter. At what distance from the optical center of the lens an object be placed to obtain a virtual image of twice the size? So here focal length is given. So f is equal to plus 25. Focal length of convex lens is positive. At what distance the optical center the object be placed? So u you have to find. So that virtual image of twice the size. Now if object length is x, or you take height plus, then image length is twice virtual image, so plus. Virtual image is always erect. Okay, so h and 2h, so both are virtual, so standing along positive y-axis. So that's why plus h plus 2h. So this information is given. So from here you can find the relation between u and v, because I and o is given. So I by o is equal to v by u. So use this relation to get the relation between v and u, and you can use that main formula, lens formula, to get the object distance. So this is the pattern. So here I is 2h plus o h, v and u, both you don't know. Then you can write v is equal to 2u. Okay, equation 1. So here we have got the relation between v and u. Now we'll take the formula 1 by f is equal to 1 by v minus 1 by u. Then 1 by plus 25 is equal to 1 by v. Now you see this v can be written as 2u minus u. So 1 by 25. Now only the variable left is u, and solving this you will get the value of u what is required. So we have got u minus 12.5 centimeter. So u is